Good evening, everyone. Am I audible?
Yes,
Yes,
ma'am.
Yes, ma'am.
Okay. Is the start to session over?
Yeah.
not yet.
Okay. Anyway, today we'll be taking just doubts. So since all the contents of week 2 has already been covered, we'll be uh, we'll be discussing only doubts. Whatever doubts you have, you can ask. We
Yes, ma'am.
can discuss them.
Good morning. Sorry. Good evening, ma'am.
Yeah. Good evening.
I have one. I am not able to solve one and only question in graded assignment. After so many tries.
Graded. Since the deadline is not yet over, we cannot discuss graded, right?
Actually, ma'am, the similar question is also in 2.4. Activity question 2.4. It is graded assignment question number 6. After repeated trials, I am not able to solve it.
Okay.
Can we discuss
One
the
second. Let me
approach
share
to
my
solve this question? Pardon me? You were saying something?
I'll just share my screen and then.
Okay.
Yeah, maybe you can ask a similar question in activity or something so that.
Activity 2.4. ma'am.
Okay. Activity 2.4. Question number?
I just want to discuss the project. Let me check. Give me a moment. It's question.
I think, ma'am, 6.
Okay.
Yes, sir. It is question number 7
7.
in 2.4. Actually, I want to discuss approach to solve this question.
Okay.
Suppose
So the
I
question
am
is.
given.
Yeah, so what is asked? We are given a system of
Yes.
equations,
Yes,
and
sir.
then we have the matrix form. Okay, AX is equal to B. And then the reduced matrix is this. So this
Yes,
is
sir.
the reduced row echelon form of the augmented matrix. Which of the following are correct? So you just have to try and do the reduced echelon form. You'll get the
No,
answer,
but
right?
let me discuss it. So what I want to discuss is that you have given the reduced correspond form here, right?
Yeah.
And I have to somehow convert the system of equation into this form. Then only I can solve A and B.
Yeah.
Is this the right approach?
Yeah. You have to convert it to this. See, the given matrix is invertible. 6 minus 1, 5. Determinant is 5. So it is invertible. So the reduced echelon form is going to be the identity matrix, right? This portion.
I'm not getting them this. How is it possible that when the matrix is invertible, I always get, yes, you are somewhat right. I get the identity matrix.
Yeah, so you'll get this part A and B, whatever you do to
Yes.
the matrix A, you'll do for the vector B
Yeah,
also. So from that
when we do operations on the augmented matrix, A and B will be automatically calculated.
sorry, can you repeat? When we do operations on A?
When we approach this reduced row echelon form, A and B, whatever would be the values of A and B, they would be out. We would approach the values of A and B straight away from reduced row echelon form.
One more time.
Can I ask one question, ma'am?
Yes. So is this doubt clear? Like whoever asked this doubt, is it okay?
Yes, sir.
Ma'am,
Yes.
my question.
ஒன்னு ஃபர்ஸ்ட் டைம் மட்டும் பண்ணாரு அப்புறம் பண்ணல.
Can you please
Ma'am,
mute if
I
you're
want
not
to make a
talking to me?
hello, ma'am.
Yeah.
Yeah, I want to make a request. In the previous term, in Formula, there were what the questions were discussed were just similar to the graded assignment.
Yeah, there are a lot of activity questions, practice questions, and all practice assignment questions which are similar to graded, right?
Yes, sir. But what I wanted actually was a question similar to that one, which I asked in graded assignment. So that,
Did you solve the practice assignment?
yes.
அதுல நான் போட்டா எவ்வளவு வருது? 3.25 கிட்ட வருதா? log k minus 3.25.
Can you please mute if you're not talking to me? So there was no question which is similar to that in the practice
Ma'am,
assignment.
can I
is it?
ask one question?
Is it related to the same question?
Yes, sir. Yes, ma'am. It is related to the topic. Actually, I cannot understand clearly what is row equivalent form.
Okay, I'll explain that. Okay, so
Please
Naveen,
explain
it was
what
your
is
question,
Yes,
right?
sir. Yes, sir.
The
I
graded.
may.
Which question is it?
Good evening, ma'am. May I ask you a question?
Ma'am, in graded
Solve
assignment,
with
question
us-
number 6.
Uh,
Question number 6.
Solve with us
sorry, can we?
discussion session. Means
Ma'am,
We are just discussing doubts here.
ma'am, may I ask
this
a
is not solve
question?
with us, ma'am, because it is showing as a solve with us session, ma'am.
Yeah, in maths to solve with us is you sit and solve with us.
Ma'am,
So
Yeah,
we'll
actually
clear all
solve
your
with us
doubts.
means it is questions you will be share and we will joinpt.com. We will share our
No,
answers.
we don't do that
Can
in
you
maths
once
too.
look at the question number 6 in graded assignment?
See, the question numbers will be different, and it is not necessary that the question may even appear for everyone. So you have to tell me what is the question.
It is what
It's not there
row
on mine,
echelon
is
form
it?
is row echelon form is given, and we have to tell the sum of elements A, B, and C of the matrix.
Yes, ma'am.
I
Same
don't
question.
think
How
it's
to
there
reverse
for
the
me.
process?
Is it this?
This one. Yes, yes.
Yes,
Okay,
yes,
the
ma'am.
first.
After repeated trial, I am not getting -1/2, whatever. I tried it so many times.
The row, okay, the first, first, second, third, and fourth columns are this.
Ma'am, this question similar to the activity 2.5, question number 6, I think.
So the columns of A are given.
Yes,
You have to
I
reduce
have
it to this form.
I
You
have
have to bring
to.
it to this form. Yeah. So
Yes,
when you do the
what
operations, you will end up with A plus B plus C.
Actually, I am not ending with A plus B plus C. Actually, I am not getting what this values are -1/2, -7/2. In first row, I was getting 1, 3, and I have no way to reduce
Okay,
this
maybe you should
3.
keep trying till the deadline is over. After the deadline is over, we can discuss this problem. Anyway, the solutions will be up on the portal.
Okay.
Hello, ma'am.
We
Ma'am.
cannot discuss
Similar
it,
question,
right?
Hello,
if we can
madam.
discuss, then it would be okay.
Ma'am,
Hello,
A
ma'am.
We
similar
will discuss
question
after the
in
deadline
your
is
question
passed
9.
in the next session.
ma'am, may I ask a question?
Hello, ma'am.
Yes.
Ma'am, please.
I have same doubt, madam. Hello.
Yeah.
I have same doubt in graded assignment 2. How do we find maximum and minimum value of variable through system of linear equation? One question asking about that, ma'am, in graded assignment. I just want to learn concept. How do we find maximum and minimum value of variable through system of linear equation?
Of a function, is it?
Yeah, no, system of linear equation I've given, and
Yeah, but when you
one
do something to the system of linear equations, are you getting a function?
no, madam, no function is not
No, ma'am.
there.
It
I
is
think
just linear
it's a
equation.
simple question number 15, graded assignment, and system of linear equation is given, but uh, they are asking maximum and minimum
This one,
value
is
of
it?
it. Yeah. Yes, madam. Here the column A, and the
This
second
is
column B,
straightforward, I guess.
but it is asking maximum and minimum value of variables, madam. That's right.
Hello.
Yeah. And we can calculate average, but how to calculate maximum and minimum?
Okay, I don't remember, but this, as far as I remember, this was a very straightforward
Yeah,
question.
question number 15, madam. Yeah, it is asking maximum and minimum value.
Yes, ma'am.
How do we find maximum and minimum value, madam, of a particular variable? When we solve augmented matrix,
Hello.
we need to use. Is it only possible when a solution or many solution? I think infinitely many solution. then we can think use maximum and minimum.
Um, I don't know. Again, it's a graded question. I don't want
Okay,
to sit and solve it. Only if I start solving it, I will understand what is happening because I don't remember. Yeah.
Ma'am, may I ask a question, please?
okay,
Yes, please.
okay, madam.
Ma'am, I want to know the difference between the row echelon form and row reduced echelon form. I'm confused. So please explain
Yeah.
this thing.
Yeah. Someone else had also asked about what is a row echelon form, right?
And reduced row echelon form.
Yeah. So,
Hello, ma'am. I have a
so
doubt in activity question.
yeah. So shall we finish this and then go to that?
Okay, ma'am.
Yeah. So what is row echelon form? When do you say a matrix is in row echelon form? Can someone tell me? Just one of you maybe.
Ma'am, the
Leading-
leading
The
entry
elements.
of a row should start with 1.
Yeah. The leading non-zero entry should be
Yes,
1.
non-zero.
Yeah. And then?
And then all the, the row where all entries are 0 should be should be below the non-zero row.
Yeah.
So
0
the second
rows
what then?
should be at the bottom.
Yes. And ma'am, all the leading entries, like the leading
And then,
entry
ma'am,
with one or the next should start from the right, should go to the right.
ma'am, yes,
Yeah.
the
What can you tell
leading
about the
entry
entries
of
below the leading entry?
Should be
it
zero.
should it's
It should be to the right of
Zero, ma'am.
this leading entry.
Zero.
All
yes,
entries below the leading, below the pivot
entry,
should be 0, right?
Yeah.
yes, in that particular column.
Yeah. Yeah, all entries in the column below the pivot.
The leading zeros should, when it goes row wise, it should go diagonally towards the right
Yeah.
of next row.
Ma'am,
The number of zeros, the number of leading zeros in each row should be greater than or equal to the number of leading zeros in the previous row, right?
Yeah.
So if all this is satisfied, the matrix is said to be in row echelon form.
ma'am, please give me the example. One the
Yeah,
row
I will.
echelon form and one the reduced row echelon form. That will be sufficient.
Sure. Yeah. So this is in row echelon form. In addition to this,
I
what is
cannot
it?
understand the third point.
Yeah, I will give an example and explain.
Yeah.
Reduced row echelon form. What is the condition here in addition to the above?
The column values above the leading one should also be 0. That is, the complete column should be 0.
Yeah. So this should first be in row echelon form. In addition to that, a column containing the pivot should have only the pivot as a non-zero entry, right?
As one.
Excuse me, ma'am.
Yeah.
What is pivot here?
Pivot is the leading non-zero entry.
Ma'am, as one or non-zero, ma'am? For reduced row echelon form.
It should be 1. That should be the only non-zero entry. Yeah. So pivot means for us it is 1.
Okay.
That is the only non-zero entry of the entire column. Okay. So let's take an example. 1, 2, 3, 0, 4, 5, 0, 1, 0. Is this in row echelon form?
No, ma'am.
No, ma'am.
Okay. Why not?
Because of the second row,
Because
there is
second
not
row
one as a
leading
leading
entry,
entry.
not their leading entry.
Okay. So in the first row, the first non-zero entry is in the first column itself, and it is 1. So no problem. and all the entries below that pivot are 0. So it is fine here. In the second row, the first non-zero entry is 4. That's not equal to 1. So this is not in row echelon form. So now suppose this is equal to 1. Now,
excuse me, ma'am.
It is then also it's not
sorry to interrupt.
because of the third row.
Yeah.
It should lie the right side of the column containing the leading entry of second row.
So once
Ma'am,
you
I
identify
want to
a
ask-
pivot,
Third row, second column should be 0, ma'am.
yeah. Someone wants to ask a question. What is it?
Yes, ma'am. My question is, while reducing a system of equations to reduce to echelon form,
It's upper matrix. It's upper matrix.
From where should we approach it? Is it a way or some technique, or it is just the observation of?
No,
we
you
should
do
approach
elementary
it
row operations and bring it to echelon form, right?
by whatever means. We don't need to start right from column 3. We have to start from column 3 or from column 1. We can start from anywhere.
Yeah, you can start from anywhere, but what we ideally do is first you go row wise, you take the first row, identify the pivot, try to make the entries below the pivot 0. That's what you do, right?
Okay.
Yeah.
Okay. That should be the approach.
That makes the sense for placing the zeros with all row with all zeros. It gives us a sense
at the
of
bottom.
bottom.
Okay. So now, since this entry is 1, the pivot in my second row is also identified and it is 1, so no problem. But below the pivot, all the entries should be 0. So this is not in row echelon form because this entry is not 0. But suppose this entry is 0. Now is it in row echelon form?
Yes, absolutely.
No. It's still not in row echelon.
Yes.
Why not? Why is it not in row echelon form?
In second column, we have a leading entry 1 and above 1 is 2 in second column.
No, this is in row echelon form. Row echelon form doesn't say anything about the entries above the pivot. It only says about the entries below the pivot.
Okay, it's in row echelon.
Because last row have zero element. That's why it is.
So you're telling it's not in row echelon form, is it?
No, it is in row echelon form.
So this is now in row echelon form. Okay, so someone had asked, what does it mean to say the third point? The number of leading zeros in each row is greater than or equal to the number of leading zeros in the previous row. So this is not in row echelon form because the number of leading zeros here is 1 and the number of leading zeros here is 1. Okay, we cannot give that as a reason here. It's obviously because the pivot here, right? The element below the pivot has to be 0. That is the reason this is not in row echelon form. What about this one? Is this in row echelon form?
No, ma'am.
No, ma'am.
This is not in row echelon form because the number of leading zeros here is it satisfies everything else, right? The pivot here is 1. All the entries below the pivot are 0. The pivot here is 1. The entries below pivot are 0. Everything is fine. But the leading zeros here are more than the leading zeros here, which is not okay.
Ma'am, in the second example, ma'am, in the
rows.
Ma'am,
yeah. Yes, in the second
ma'am, in the
example.
second example, if I exchange row 2 and row 3, then it will be a row equivalent form. No?
Yes.
If I exchange row 2 and row 3,
yes,
then
it will be in row echelon form.
Then it will be.
Okay.
That's what I want, right? Because the number of leading zeros here is 2 and the number of leading zeros here is 1, which is not okay.
It is not in increasing order. It is decreasing.
Yeah, the number of zeros should be in increasing order. The leading zeros, right?
Ma'am, I have a question, ma'am.
Yes.
You said like number of leading zeros. Like, can we understand the same point as the pivot element should be moving diagonally towards the right? Is that the same as what you say, ma'am?
Yes.
Okay.
Yes.
Not always
because
not
when the number of zeros increases, the pivot is going to occur here, right? So it's moving to the right.
Okay, ma'am. Okay.
So is it clear what it means to be in row echelon form? Matrix is in row echelon form.
Yes, ma'am.
Yes, ma'am. Ma'am,
So
ma'am, I
now,
have a question.
yes.
Ma'am, is it possible that all matrices can be reduced to reduced row echelon form?
Yes, every matrix can be converted into reduced row echelon form or row echelon form.
Okay.
Ma'am,
Okay.
ma'am, you
Yes.
have given in point number 3 greater than or equal to. It should be only greater than, no, ma'am?
No, it can be that all the entries are 0, no? In that case, it will be equal. Like this case.
Ma'am,
Right? Yeah.
sometime after manipulating the rows, we find that all the entries for x1, x2 up to xn become 0. Then there will be a no solution. Na? If any row becomes 0, then we can conclude that there will be no solution.
No, no, you cannot always conclude. It depends on what your right hand vector is. Right?
Now, if right at the last column, if the suppose you have a augmented matrix. Suppose you have a augmented matrix. In the last row, you find that first 3 column values are 0 and the last entries have some value. Yes.
Okay.
In this form. Okay, then what is the conclusion?
Then it is no solution, right?
X1, X2, X3 are 0.
Yeah, what does this say? This says 0 times x1 plus 0 times x2 plus 0 times
No
x3
solutions.
is equal to 2, which is not possible, right?
Sometimes after row manipulation, okay. Then
Yeah,
if
because
it comes, we should thought that my processing of rows is not okay. I have
no,
to
why?
recheck.
There is no solution. That's it. In this
Oh
case,
no.
there is no solution. That's it.
I want to ask a question related to this.
Hello, madam. Is it
Ma'am, while
is it
solving a system of equations, is it mandatory to convert it into reduced row echelon form and then only we can solve it? Can we
No,
derive
you
the
can
solution
reduce it to
from
row echelon form as well.
we can derive the solution from row echelon form as well, right?
Yeah, yeah.
Okay, thank you, ma'am.
hello, madam?
Hi, ma'am.
Yes.
Is it whole augmented matrix in row reduced echelon format? Is it here?
Is it what? Is it whole?
Can you say that this what you have written augmented matrix is in row reduced echelon form?
No, it is not,
Whole
right?
No, not.
This has to be 0, no? If it has to be in reduced row echelon form.
reduced row.
This is in echelon form, but
Okay.
this is not in reduced row echelon form because this is a pivot. And above the pivot also, we should have zeros, right?
But 2 is there, madam. How is it in row echelon form? 2 is
Where
here.
2 is there? Here.
In the yes.
No, how does it matter?
Yes,
Oh, you mean you want to make it 1, is it?
Yeah, yeah.
Okay, fine. Even if it is 1, it's still not in reduced row echelon form, right?
But it is row echelon form.
Yeah, this is in row echelon form. Even if 2, oh, okay. If 2 was there, it is not in row echelon form. Okay,
Yeah,
fine.
yeah. That's why.
Okay.
Ma'am,
Yes.
ma'am, suppose we have a matrix where the independent column is all 0.
Okay.
Okay.
What do you mean by independent column?
Then that independent variable, I think, is a 13
Ma'am, as
reduced row echelon
all
form while solving that. Ma'am, can you just please take an example? But
For
I'll
what?
say
For reduced row echelon form, is it?
yes, ma'am.
Yeah,
Ma'am,
okay. So let me first tell what
suppose
reduced row echelon form is. So this we know now it is in row echelon form. If it has to be in reduced row echelon form, wherever there is a pivot, that should be the only non-zero entry in the entire column. So this, because there is a 2 here, it is not in reduced row echelon form. If that is 0, now it is in reduced row echelon form, right? That's the
yes.
only difference. The entries above and below the pivot should be 0, means in that column.
The last row should be 1 in the last column. I think
Here
what we
is
have
it?
studied. Yeah, it should be 1, the last column row, the
No,
last
not
row.
necessarily. No, you are allowed to have even zeros.
Ma'am, the right
Okay,
side matrix, is it in row echelon form?
Yes, it is in row echelon form, but it is not in reduced row echelon form, right?
Okay, in case if we swap the second and third row, then?
It will not be in row echelon form is it itself, right? If I've swapped the second and third row, the number of leading zeros in the second row will be more than the number of leading zeros in the third row, right?
Okay, in case in the third row, if we have 0, 1, 0, then?
0, 1, 0, okay then.
Yeah.
Now it is not in row echelon form. But if you swap row 2 and 3, it will be, right?
Yeah. Thank you.
Okay.
Ma'am, the first matrix is in reduced row echelon form, right?
Yes.
But
Because these are my
we have
pivots.
3 and 5 as well over there. So can we reduce it further?
No, why do you want to disturb it? Everything is satisfied, right? You have 2 pivots.
So
below the pivot, above the pivot, it's all zeros. The number of zeros in
pivot, you mean 1, the first
yeah,
one?
the leading non-zero entry of each row. Yes.
Okay. Got it. Thank you.
Yeah.
Ma'am, in this augmented matrix, if the last row is 0, 0 and no solution is fine, even if second and first row if have a lot coefficients, many coefficients, if then we say it is no solution.
No, it's not necessarily. So what you will do is, you don't study rank in week 2, is it right? Do you know what rank is? No, right?
No, ma'am.
Okay. So now, suppose you have something like this. What does this say? What does the third row say?
It's
0 is
Zero
equal
equals
to
to
0.
0.
It has
That
infinitely
is
many
fine.
solutions.
It's infinite solution.
No, not always. It's just saying 0 is equal to 0. That's it. So that's not going to give you any information. Now from the second row, what information do you get?
X3 equals to 0.
Yeah, 0x1 plus 0x2 plus 1 times x3 is equal to 0. So x3 is equal to 0. Okay. What about the first equation?
x1 plus 2x2 plus 3x3 is equal to 0.
X1 equals to
I already know
2x.
x3 is 0, so I can take this off. So
X1 equals to minus 2x.
x1 is equal to minus 2x2.
That is many
And because
infinitely
the
many
third row is
solutions.
completely 0, I don't have any information out of it. And I'm losing out on some information, right? Now I can keep
the determinant of this matrix will be 0.
The determinant of which matrix?
Yes, this matrix.
Second one matrix.
Yes.
Yeah, yeah.
Okay, thank
That
you.
is why when you reduce it, you're having a 0 row.
Ma'am, supposing we
So in
have
this case, you have infinitely many solutions.
Yes.
Okay.
Am I audible to you?
Yes,
so we
and
can, ma'am, we can say
ask?
infinitely many solutions we can find.
Yeah, you have infinitely many solutions. You also know, no, that the solution is of this kind: minus 2x2, comma x2, comma 0. x2 can be any value.
Ma'am, in this question, what is the dependent and independent variable?
Yeah, you tell me.
X1 equals to dependent, X2 and
Ma'am,
X3
same
independent.
question.
No, is x3
Okay,
independent?
no, X3, yes, X3 is dependent. X3 and X1 is dependent.
Columns where you have pivots, the variables corresponding to columns where pivots
X1 is
occur.
dependent. Ma'am, actually, it's
Yeah,
not a
x1 is
reduced row
dependent.
echelon form. So we can't
Okay,
say
fine.
about, yes. Then X1 and X3 are dependent and X2 is independent.
Yeah, whenever there is a pivot, those variables are dependent. The second
yes.
column, there is no pivot, which means that x2 is independent.
So same question asked in mock test where I got wrong. Can you please Dependent, independent.
Yeah,
Which
ma'am. I'm
question?
also not getting it exactly.
Ma'am, can we ask question from different topics also?
Different topics in the sense week 2, any topic is fine.
Ma'am, please repeat
I have
dependent and
doubt in
independent.
activity.
Cannot understand.
Okay.
And,
So
I want
ma'am,
to
please
advise
repeat.
you something. In mock test which we have given, all the solutions have vanished, ma'am.
yeah, I have informed the support team. We'll see what they say. I've informed. Okay, so let's discuss independent and dependent variables. So you reduce a system to reduced row echelon form, RREF. You do RREF to the system. Whenever a columns with pivots, the variables corresponding to columns with pivots are dependent variables. And the variables corresponding to columns without any pivots are independent variables. It's clear, no, why that is the case?
Pivot means leading one.
Yeah, pivot means the leading non-zero entry.
And
And
this
that has
dependent variable.
Example so that we can understand more correctly.
Yeah.
And ma'am, this dependent variable will always occur in an unique equation.
Dependent variable
always occur in one unique.
Yes.
Yes.
Yeah. The dependent variable will occur in a unique equation because below and above the pivot, all the entries are 0, right? And if it is a dependent variable, that's going to correspond to a pivot, right?
Ma'am, pivot means always the leading variable is 1.
Yeah, that's the first condition for row echelon form, right? You want the leading non-zero entry in each row to be 1. That is called the pivot.
Okay.
Yeah.
Ma'am,
So in this case,
I have a
is the
question here.
yeah. Let me finish this example. In this
Okay,
case, is the matrix in reduced row echelon form?
Yes,
No.
ma'am.
Yes, ma'am.
Yeah. So there is a pivot in this column. There is a pivot in this column. There is no pivot in the third column, right?
Yes.
Yeah. So these variables corresponding to these columns are dependent, and the variable corresponding to this column is independent, right?
Yes, ma'am.
Yeah. It's obvious, no? Whenever you have a pivot, x1 plus 3x3 is equal to 1, x2 plus 5x3 is equal to 2, and then 0 is equal to 0. So whenever you have a pivot, I can write it like this, right? Whenever there is a pivot, you can take all the other variables to the other side, and then you can write that variable as something, right?
Yes, ma'am.
So it's going to be dependent on the other variables.
Can we say that if we have even one independent variable, then we have infinitely many solutions?
Yes, definitely.
Ma'am,
It depends on this 0 as well, okay? Means you take the augmented matrix and then you tell that. Yeah.
It should be 0 if it has to have infinitely many solutions. Otherwise, it doesn't have a solution.
No solution. Yeah.
Ma'am,
Yes.
what is meant by
Can I
unique
ask
solution?
question from different topic?
Yeah,
Ma'am,
let's
what is
finish
meant by
this and
unique
then.
solution?
When you have a unique solution, there is a pivot in each row, that's all.
Presents one value for x1, x2, x3, or same values x1, x2, x3 is equal to
No. This is a unique solution to this system. Means if it is a solution.
Ma'am,
Okay,
one
means
more
unique
doubt.
interaction between
Unique
those
means
three
you have
lines.
only one
Find
solution.
the value of x3.
Okay, ma'am.
Yeah.
Ma'am, in
Ma'am,
this
please.
question,
For example, how can we find the value of x3?
X3 is independent. So you can fix the value.
Any C.
Okay, constant term c like this.
Yeah, C. And then 1 minus 3C, 2 minus 5C. From here.
Ma'am, I want
Ma'am,
to
in
ask
this
a question.
Okay, understood.
Ma'am, suppose we have a matrix. Can you please write it down?
Yeah.
Ma'am, suppose we have a 3 cross 3 matrix, 1
Okay.
0 0,
Huh?
0 1 0,
Okay.
and 0 0 0,
Okay.
and multiplied by a column matrix x1, x2, and x3.
Okay.
And the B matrix is 0 0 0.
Okay.
So, ma'am, what will be the solution for this?
Can you tell me one
X1
No
solution?
solution.
Infinitely many solutions. Because x3 is
No
independent.
solution.
No solution.
No
X1,
solution.
0,
When you have a
x2, 0.
homogeneous system, you always have a solution.
No,
Ma'am,
Infinitely many
yes,
solutions,
yes.
ma'am. 0 and x3 is
ma'am,
C.
actually, the thing is, we can find an equation with x3 here.
So what is
Can
this
we find?
reduced to? See, first of all, tell me what are the independent variables, dependent variables?
x1 and x2.
Dependent x1 and x2.
Yeah, there are two
X1,
pivots,
X2
x1 and x2
dependent.
are dependent, and x1 is equal to x2 is equal to 0, right?
Yeah.
Yes, ma'am.
x3 is independent, so you have infinitely many solutions. 0, 0, C is a solution. C can be
Yes.
D.
It can be anything.
Can I ask next question?
Yeah.
So, ma'am, if we just multiply these two matrix, then will it become x1, x2, and 0 is equal to 0 0 0?
No. You put, means in the place of x1, x2, x3, you put 0, 0 something, and then you multiply, you will always get 0, 0, 0.
No, ma'am. Ma'am, I mean, put that back again, x1, x2, x3, and do the multiplication.
Yeah, so you'll get x1 is equal to 0, x2 is equal to 0, 0 is equal to 0. Right?
So that means 0 into x3 is equal to 0.
Yeah, that's known, right?
So that's why x3, we can put any value in the place of x3.
Yeah.
You can put infinite values in x3, and then also you are getting 0. That is
Okay,
going to
ma'am,
help
got
infinite
That's what is this 0, 0, C.
Yes,
ma'am.
Ma'am, I have one question.
Huh.
If any row is 0, like this example, then we will conclude that it is a no solution or multiple solution.
Not always. Take this for example. So what is the, when I reduce this system, what do I get?
One row is 0.
Something
Yes.
like this I will get, right? Forget the augmented matrix part, the right hand part, but I will get something like this.
Yes.
Oh, okay. I think I need to include this part also. 1. This is going to be 1 minus 1, 2 minus 1 is 1, 0 minus 1 is minus 1, and then now I have a 0 row, right?
Yes.
But still I have a unique solution, right?
Yes, ma'am.
Y is minus 1, x is minus 1 with plus 1, 2, right?
Yes. Yes.
Yeah, so even though you have a 0 row, you still have a unique solution. That's because you have more information than what is needed. To determine two variables, 2 equations are enough, but I have 3 equations, of which one is just a repetition of the other, right?
Actually, my question is, by observing the augmented matrix after manipulation of row, how can I conclude that it is a unique solution, multiple solution, or no solution? This is actually my question.
Yeah, you will study how to do that when you study rank. Just by looking at it, you can tell. But currently, you just substitute. So this is my reduced system, which means that 1, 1, 0, 1, 0, 0, xy is equal to 1 minus 1, 0. right? So what does
Yes.
this give you? X plus y is 1, y is minus 1. So substitute
Yes.
this here, you will get the value of x. So you have a unique solution.
After solving, we can say that.
Yeah, yeah. Just by looking at it, you have to wait 1 more week.
Ma'am, can I ask a conceptual question regarding another topic? Ma'am, can you please write it?
Yeah.
Ma'am, as we know that the system of linear equation can be solved by Ax is equal to b, as order is 3 by 3, 3 by 1 and 3 by 1.
Okay.
Ma'am, can we solve the same equation by x transpose into A is equal to b transpose?
X transpose A transpose is equal to B transpose, right?
No,
You're just
not A
taking the
transpose.
transpose.
No, not A transpose, only A. X transpose A is equal to B. Yes, ma'am.
B or B transpose? Okay.
B transpose.
Huh. No, you might not get the same system, no?
Why not same?
1, 2, 3, 4. X1, X2 is
Ma'am,
equal
for
to
3 cross 3.
2 cross 2, 3 cross 3 doesn't make a difference, right?
Doesn't make a difference, right?
Yeah. So this is my system. X transpose A means X1, X2, 1, 2, 3, 4, 1, 1. Okay, 1, 1. So this is X1 plus 3X2 is equal to 1. 2X1 plus 4X2 is equal to 1. But this is a completely different system. X1 plus
This is a
2X2
different
is
system
1.
of equation. This is different.
Yeah. This is a different system from this. If you do X transpose A transpose, then you will get the same.
Yeah.
Okay,
ma'am.
A transpose is needed.
That's because you just do this. AX is equal to B. AX transpose is equal to B transpose. AX transpose is X transpose A transpose. That's it.
Okay.
Yeah.
Thank you, ma'am.
Ma'am, AX transpose is equal to X transpose into A transpose.
Reverse law. It's like inverse, no? Like that, this also follows a reverse law.
Okay.
In the previous example that you were telling right now, xy, yeah. So if we add another variable, then it means like it has infinitely many solutions, right, ma'am? If the last
yeah.
row. Okay. And one other question I have is like in the video, in the week 2 video lectures, from the week 2 video lectures, what I understand is if the last row has 0 and the right hand side is also 0, it has infinitely many solutions. And if the right hand side has some value, it has no solution. That's what I have understood. Is my understanding not correct, ma'am? Because you said to conclude that we need to also understand the rank.
Yeah, so in this case, you see that the last row is 0 and the last entry of the right-hand vector is 0, but still you have a unique solution, right?
No, this case is different, man, because the number of variables is different. What I'm asking,
yeah, if you have a square system, yes. If the last row is completely 0 and the right-hand vectors, that corresponding entry is also 0, then you have infinitely many solutions.
Okay, okay.
Because when you have a 0 row, what it means is that one column does not have a pivot, right? That is why you have a 0 row.
Yeah.
So when there is no pivot, it means there is a corresponding independent variable.
Okay.
Yeah. Did you people attend the mock test?
Yes, ma'am.
Yes,
ma'am.
Yes, ma'am.
Okay.
Hello, ma'am. I have a doubt activity question.
Ma'am, actually, I have a related question to this. Can I ask?
Yeah.
Yeah,
so we'll get to the
here
activity question after.
Yeah. So, ma'am, here we understood that how to identify dependent and independent variable in matrix form, right?
Yeah.
Yeah, but if it will be in a linear equation form, then how will we identify? Because we had a question in mock as well.
You know to identify when it is in the matrix form, and you know how to convert a system to matrix form, right?
Correct. Ma'am, but can you please take an example?
Can you tell me what is that question?
Can you write? Yeah. I will say the question. Ma'am, it was something like 0x1. I remember.
This
yeah,
one.
this one, yeah.
Yeah, so you just put it in the matrix form and then you tell me. It's obvious, no? The columns that don't contain pivots are independent variables.
Yeah, correct.
So the first column is 0, it does not contain a pivot. The
Pivot.
second column contains a pivot. The
Yeah.
third column does not contain a pivot. Or does it? We
Yeah,
should
it does.
write down. Oh yeah, this will be the pivot, the coefficient of
Yeah, yeah, it does.
And the last column does not contain a pivot, right?
Yeah, it doesn't.
Yeah.
So,
So
2
you'll
will be
have
done.
2, yeah.
Okay, got it. Thank you.
Yeah. Yeah, there was someone with a doubt in activity question, no?
Yes, ma'am.
Ma'am?
Yeah.
No, ma'am, in one
Activity
can
2.
we finish the activity? Yeah.
Ma'am, so
I
it
joined.
only depends on the pivot. It doesn't depend on the second equation if there is one or not.
It
Like
depends on the
X4.
pivot. There is a pivot in the second equation as well, right?
Ma'am, can you please solve this, please?
No,
This
I'm
question.
just asking about X4, ma'am.
So this is the equation, right?
Yeah.
1, 0, or was it not 0?
Yeah, it
1,
is
1,
correct.
0,
1
1.
0. 1
1,
1.
1, 0, 1.
0 1. Yeah.
1, 1.
Yeah, correct.
Yeah. So this is already in, this is not in reduced row echelon form. Is it in row echelon form?
Yes.
Yeah, it
Yes.
is.
It is.
Yeah, it is, ma'am.
It is in row echelon form. This is my
Yeah.
pivot here.
Yeah.
If I want to make it reduced row echelon form, it is not in reduced row echelon form because this is.
Yeah, we can subtract.
You can R1 minus R2.
Yeah, you can do all that and make this 0 and all that.
Yeah.
But this column does not have a pivot. This column does not have a pivot. That is what we are interested in, right?
Yeah, yeah. And that's what
So
matters.
X1,
right?
yeah, X1 and X4 are independent.
I just wanted to ask that we can't feel that why it is not, independent and why it is dependent.
So that's because from the first equation, you can write X2 is equal to 1 minus X3.
Okay.
X2 is 1 minus X3. From this equation, you can write X3 is equal to 1 minus X4.
X4, right? Right.
Yeah. So I have a pivot here in the sense that, okay, this is not in reduced row echelon form. Okay, let's make this entry 0.
Yeah,
we have
0.
done some calculation and this has become 0.
The last column will also be 0 of upper part.
This one, is it? Okay.
Yeah, yeah.
Okay, fine. So this will be something else, is it? 1. I think this will be 1, no? 1 or minus 1 or something.
Yeah, minus 1. The fourth one. Yeah.
Okay. So something. So I have X2 is equal to 1 plus X4. So you see that I have an expression for X2, right? X2 is clearly dependent on X4. Based on what the value of X4 is.
Yeah.
Yeah, so this is dependent.
Okay.
Similarly, X3 is dependent. X1 is not even appearing anywhere.
Yeah. So if we can write in the form of other variables, so we can say that it is Got it,
So
thank you.
X1 and X4 is independent.
Yeah. Because there are no pivots in the column.
Yeah, generally we can just say by pivot, right?
Yeah, yeah.
Okay, thank you.
Ma'am, there is a question that how many number of solution for the system of linear equation? Now, what will be the approach that how can we find the number of solution? That means X, Y, Z have more than one solution.
Is it this one?
Yes.
So it can either have no solution, that is 0 solutions, or it can have one solution, or it has infinitely many solutions. There is nothing in between.
No solution.
And it was straightforward that there is no solution.
Okay. So you have to do the manipulation and find out whether it has a solution, does not have a solution.
By adding second and third, we are getting x plus y is equals to 4.
Okay. So no solution.
Yeah.
So the number of solutions is 0.
Yeah.
Is it clear? There is nothing in between 1 and infinity.
0, 1 and infinity. Three values will be there.
Ma'am, in the previous question, that equation is not in the reduced row echelon form, and we are asked about the number of independent variables. So, will we have to first reduce it into Reduced row echelon. Okay.
Yeah.
Okay. Then the number of
do that reduction.
after reducing it, the new matrix what we found, the number of independent variables will be equal to the number of independent variables of the main, I mean the
Original
base
system.
equation. Okay.
Yeah. Yeah.
Okay. Okay.
Ma'am, I am facing difficulty in this reduction in row echelon in this question particularly. Please, can you solve it?
This question, is it?
Like after subtracting, what will be the values?
So you have this.
Ma'am,
Yeah.
we can only take the left hand, I mean the A matrix here. Why do we need to take that augmented
No, you don't
matrix?
need A. You don't need B. You just want the number of independent variables, right? So you don't need B. Okay. So now this is a pivot. This is a pivot. Is that clear? Whoever asked the doubt?
Yes, ma'am.
Yeah. So to make it to reduce row echelon form, I have to make this entry 0. Everything else is fine, right?
Yes, ma'am.
Reduced row echelon form means the only non-zero entry in the column containing the pivot should be the pivot. That is, this should be the only non-zero entry. Everything else should be 0 in that column, right?
Yes,
okay.
Yeah. So now you want to make this entry 0. To make this entry 0, what can you do?
R1 minus R2.
Actually, we
subtract the bottom row from the first one.
That's it.
We can only apply
Second
the
row
type 3 transformation here.
0
minus
minus 1.
Ma'am, for
0, 0.
finding the solution from this matrix, we should prepare reduced row echelon form or only row echelon form?
If you want to find the solution, anything is okay. Reduced row. See, the only difference is if you do reduced row echelon form, you will directly get the solution.
Yes, yes.
That's yeah, when you do row echelon form, you will have to substitute, go back, substitute, and get the value.
Okay.
Yeah.
Ma'am, you
So
said,
is it clear now that it is in reduced row echelon form? Whoever asked the doubt.
Yes, ma'am.
Ma'am, one doubt.
Huh.
You made the third element of first row as 0.
0. Yeah.
At the same time, we are able to see that the first element has become -1.
Yeah, it doesn't matter, no, what that element is.
Okay.
Yeah, because this is my pivot. I want entries above and below it to be 0, which is satisfied.
Okay.
That's it.
Okay. Okay.
Above also 0. Okay.
Huh.
Right.
I have a question.
Yeah.
Yeah, ma'am, when we talk about elementary row operations, the type 2, that is scalar multiplication of any row with a constant.
Okay.
So that scalar can be 0 as well?
No.
For some question.
Why do you want to multiply by 0? Like?
Because actually there is a question in graded assignment that when we, if we do some elementary row operations, that then the resultant matrix can be invertible or not. So if we multiply
no, you shouldn't. Then every matrix is not invertible, right? You can multiply by 0.
Yeah. So we do not consider 0 when we talk about row elementary to row operations. Okay.
Yeah. In type 2, you multiply by a non-zero constant.
Okay, that was done.
Yeah. Yeah, there was someone who had a doubt in AQ activity question, and
Yes,
I had
ma'am.
asked them.
Yes,
Yeah.
ma'am.
Yes, ma'am. 2.5. 2.5.
Ma'am, 2.1, question number 4.
Yeah, we'll do 2.5 first.
Question number 1. In question number 1, the second column, there is a not specify which column I can do these operations. So how to find the solutions of these questions?
This is the notation that sir has used,
yes,
right?
that is not
R3.
This is not indeed there for R3, for R3 or for R1.
No. See, this is the notation that sir has used in the lectures, which means that R3 is replaced with R3 minus 2R1. R2 is replaced with half R2. Whatever is the first thing, no? First.
Yes.
in here. That is the row that is getting replaced.
Okay, ma'am. Or question number 6.
Okay. Question number 6. Huh.
So I can't find the solution of this question. Can you solve it?
Oh, this is
So how to find
exactly
M1
similar
plus?
to the
Yes.
one that someone had asked in graded, right?
Yes, I told you, ma'am.
So 1 0 0 1 minus 1 1. So this is the reduced echelon form, is it?
Yes.
Yeah, this is the reduced
Yes,
echelon form. First and third columns of AR.
Replace
1 minus 1 1.
2 minus
2
1.
M1 M2.
M1 M2, yes, M1 M2 2 minus 1. Yes.
Okay, then find the value
I
of
need to find M1 plus M2.
okay. M1 M2, the second column. Okay, fine. Okay, so this is my given matrix A, and this is the reduced echelon form of it. Okay. So minus 1 M1 2 1 M2 minus 1. What can I do to make the, what is the first step?
Interchange row.
We can just interchange the row here.
Yeah. So 1 M2 minus 1 minus 1 M1 2. Next.
And then we should make that the first entry of second row 0.
Yeah, you've identified a pivot. So everything,
R2
every
plus
element
R1.
below the pivot should be 0.
R1 plus I2.
Yeah.
And then the only transformation we can perform here is type 3.
Okay. So is there any problem with
while
it?
converting to 0.
Okay. So is there any problem because of that?
No.
Okay, fine. So M1 plus M2 and then what? 2, 1. Yeah. So you've already got, right? What is M1 plus M2?
1.
Right?
This is similar to a first matrix or given matrix.
Yeah, this is the reduced. This is the reduced echelon form.
Okay, ma'am. This is the main concept.
Ma'am,
I didn't understand why we interchange row 1 and row 2.
You can even multiply row 1 by minus 1. It doesn't matter. I want to make this entry 1. I can do anything for that.
Yeah, okay.
Ma'am, I have a small
Ma'am,
question.
for getting row echelon form, should I only manipulate to rows, or we are allowed to manipulate columns only? Columns also, like C1 plus C2 or C1 into 2 minus
You either
C2,
do row
like.
operations or do column operations. You cannot mix. But it's better to do row operations, because in the context of linear solving systems of linear equations, it's only row operations that are permitted.
Ma'am, I have a small doubt here.
Yeah.
Ma'am, like in row 1 and row 2, like sometimes we have a, let us say, plus 1, and row 2 I do have minus 1. Now I can, like, if I add both of them, I can get a 0. Let us say I am targeting to make a 0 in the first one. Instead of minus 1, I need to have 0 there. So I can do, let us say, R2 minus R1 or R1 minus R2. In that case, now do you have to stick to that? Okay, only row 1 should follow, then only we should make the row 2 minus. Yeah, like, is there any way?
No, are you trying to make this entry 0?
Yes, ma'am. Let us say I am targeting to make that. I do have one more row. Let us say I do have 3 rows and 3 columns, and that is the second row, and which I would like to make the 0 entry in order to make the reduced echelon form or the echelon form. In that case, I need to make that 0, right? So in that case, do I follow that? Okay, row 2 plus it has to be row 3, or can I make row 3 plus row 2 or row 3 minus like that? So,
You can do anything. It's not necessarily with row 1.
No, ma'am. Actually, do I need to follow an order? For example, I need to make that. Let us say, can you make a 3? Yeah. So.
This is your question, right?
Yes, ma'am.
You're asking, can I do R2 is equal to R2 plus R3 to make this entry 0, right?
Yes. No. Please make that one positive one and row 3 is negative one.
Okay.
Something so that I need to do a minus thing which is equal with R1 and R3 also. So should I go to only R2 changes by R2 minus R1 or R2 R3 minus R2 like that?
R3 plus R1 or do R3 is R3
No, first
what?
yes. One is R3 plus R1 or R1 plus R1 minus R3 like that.
This one you're saying, right? You can do it either with row 1 or with row 2. Anything is fine.
Yes.
Minus also, if not even plus, let us say
if it is this, then it is going to be R3 minus R1 or R3 plus R2. Anything is fine.
Ma'am, yesterday there was a mock test for week 1 and 2.
Yes.
In question number 7, there is only information. No question is there.
Question number 7 or the determinant question, I guess. Oh,
Mock
there was
test.
that. Yeah. There was one question without the. It was asking for determinant actually.
Ma'am, similar question asking in activities also.
Yes. There is
This
only.
was actually asking for determinant. Yeah, it is missing. Yeah, someone was asking from activity 2.1.
Yes,
This is lower triangular matrix, na?
Yeah, it will be either lower triangular or upper triangular. I less than or equal to j. Yeah, this will be lower triangular. Yeah, 2.1. Yes.
So, ma'am, question number 4.
Okay.
In this question, I'm confused. How to solve this one?
Choose the matrix. You have to find the determinant of it. Okay. A, B, C, B, C, A. A, B, C, B, B, A, C, A, B. You want to find the determinant of this matrix, which obviously you can do by usual way. Expand along row, expand along column, and all that you can do. But to make the calculation of the determinant easier, you can use row operations. That is the basic idea behind this question. So maybe you can do R2 is R2 minus.
We can also do R1 is R1 plus R2 plus R3.
Okay, fine. R1 is R1 plus R2 plus R3. So that's going to be A plus B plus C, A plus B plus C, A plus B plus C, and then
we can take A plus B plus C common.
So you
C1
do this,
minus C2.
and the determinant of this matrix is going to be equal to the determinant of this matrix because this does not affect the determinant, right?
Yes.
Yeah. So A plus B plus C, A plus B plus C, A plus B plus C, B C A, C A B. The determinant, this is what you want to calculate. So now I can take A plus B plus C outside, right?
Yes.
Now calculate the determinant of this. Okay, it's not even needed to calculate the determinant because I've already got one term outside. That's what is given. No, if A plus B plus C is divisible by 6, then the determinant is divisible by what all values, right?
Yes, ma'am.
So I already have a factor. A plus B plus C. If this is divisible by 6, then it is divisible by 2, 3, 6.
Okay.
Yeah, so the determinant is going to be A plus B plus C into something. I'm not bothered about the something because this is what I have, right? Yeah.
Okay.
Hello, ma'am. Can you take question number 3, same activity?
Okay.
Option number 2. So, ma'am, option number 2 also be correct. I think both A or B are 0, then determinant will be 0.
No.
It is saying must have, so it doesn't.
So what about this matrix? Oh, okay, this is bad. This is non-zero. What does it say? If A into B is equal to 0. Okay, fine.
Yes.
0. Okay, this is not
This is
0.
non-zero.
Huh. What about this one?
Yes, this is 0.
Oh, the determinants are 0. Okay, fine. Take the identity matrix. Oh, that's not going to
Okay.
give me 0 matrix. What? No, it's not going to give me 0 matrix, right? Yeah,
Yes,
what is
ma'am.
it? A into B should be equal to 0. Uh,
Ma'am, take I and take minus I.
no, but then the product will be equal to minus I, no?
I guess. So, one zero zero minus one and minus 1 0 0
It's not
1.
difficult to construct. A, B, C, D. 0, C, 0, D, 0, 0, 0, 0. So C and D should be 0. A and B can be anything. Right?
Yes, 0 0. Yes, ma'am.
Oh, but again, both are having 0 determinant.
Yes.
Yeah. You should be able to construct. It's not difficult.
Okay, ma'am.
Let me put this. A, B, C, D. So this is C, D, A. Okay, this is not going to work.
Ma'am,
Maybe a little calculation and you should be able to get it.
ma'am, let's take 1 minus 1 0 0 and another is 1 0 1 0.
But the determinant is 0 for both,
Determinant
right?
also, yes, both 0.
Oh, yes.
Why am I not able to construct one?
মনা তোর যে এই যে শোন না একটা কথা শুনে যা
The first one is identity matrix, then other is 0 1 0 0.
Yeah. No, take this, no? Take the identity matrix and the 0 matrix. That's it, right? Oh, why were we thinking so much?
Yes.
Determinant is not
Got it,
0.
ma'am.
Yeah.
Yeah, or question number 9 in same activity.
Okay. Huh.
So, ma'am, in question number 9, scroll question number 9, ma'am.
Yeah.
In this question, okay, my answer in my okay. In my activity question, in my activity section, question answer are different, so that's why. Okay, ma'am. Done. Question number 2.3. Question number 10.
2.3.
Question number 10. Option
Okay.
4. Option 4.
This is
Yes.
a 2 cross 2 matrix, no? You should be able to get it easily, no?
But I will not get an answer correctly. That's why.
So you have A, B, C, D. What is the adjoint of this matrix?
Adjoint of A, C, B, D.
A.
C.
A
C.
minus C, no?
Yes, ma'am.
Or here.
Okay, adjoint. Okay, adjoint. Yes, ma'am.
Yeah. Now you take the transpose of the adjoint. A minus C minus B.
Yes.
And similarly, you take the transpose and then take the adjoint. You'll get the same matrix.
Okay, ma'am.
Yeah.
Okay, question 2.5. 2.5, question number 8 and 9.
Sum of each entries of column is 5 and sum of first 2 elements of each column is 3. Okay.
find it. I can get the correct answer, or I can solve this question.
Now, why don't you tell me how the matrix is going to look? It's a 3 cross 3 matrix.
Yes, that is a 3 cross 3 matrix.
Suppose
But
I have
there are
A,
given,
B. What do you know about this entry?
there are given columns equals to sum of column 5.
Oh, sum of column or row? Oh, column. Okay, fine. Sum of first two elements of each column is 3. Okay, fine. So now suppose I have A, B, C and say D. Do I know this entry now?
No.
5 minus A plus D.
Okay, yes.
Yeah.
Yes. 5 minus
C, D, E, F. 5 minus E minus B, 5 minus F minus C, right?
Yes.
And in addition to that, what do I know? What is A plus D?
A plus D.
3, ma'am.
Given no sum of first two elements of each column is 3.
Okay, 3. Okay.
So this is 3.
That is 3 minus. That is 3. 2.
Yeah. So this is all. This is 2.
Yes.
And then what is the question? Determinant, I think.
Yes, determinant.
Then what do you do?
Find that is multiplied by 2.
So 2 times A, B, C, D, E, F, 1, 1, 1.
Yes.
Is it even necessary to do all this? Okay, I think it is. Okay, so this is 2 times. You expand along the third row or something. Or you can do some column operation and simplify. You will ultimately get 0 as the answer.
Yes, ma'am. We
I
can
think if you
also do
expand.
R1 plus R2 here, so that we can get 2 rows as same.
Yeah,
I
fine,
mean,
perfect.
scalar multiplication. Yes.
Yeah.
That will be
So if you
3
do,
R1 plus R2. Then it will be
so
3,
this is
3,
going.
3.
The determinant of this is going to be the same as 3, 3, 3, D, E, F,
2, 2,
2,
2.
2, 2. So this is going to be 6 times 1, 1, 1, D, E, F, 1, 1, 1. So see.
How got 3, 3, 3?
Well, we did one operation. R1 is R1 plus R2.
Okay, got it.
Yeah.
Okay, ma'am. Question
How are you
number.
reading? Is it?
Can you announce next question?
Is this the 8th question?
Yeah. It is
So,
the 8th.
so what is the answer of this? It is
0. Means the determinant is 0, so it is a multiple of every number. All options are right.
Okay. Question number 9. Yes.
Let R is a number of non-zero rows. You just need to do the reduction, right? You find the RREF and then.
Okay. I got it, but got the wrong answer. That's why.
Maybe you should just check your calculation. Yeah.
Okay, ma'am. Question number 2.4. Question number 6.
Yeah, there's someone else. No, was it in same question?
I think. Yes.
This we discussed in the previous. No, in my session, the first session of week 2. You tell me what is the answer.
I can get the correct answer. This.
What is the matrix form?
4. No, 1 by 4.
So how many pivots are possible?
Only one pivot possible.
So everything else is independent, right?
Okay, got it.
Just from the equation you can tell x1 is equal to a minus x2 minus x3 minus x4. So x1 is dependent on every other variable and all the other 3 are independent, right?
Okay. Yes, ma'am. That's okay. Thanks, ma'am.
Ma'am, suppose in this case the first entry is not 1 and not also 0, then how can I reduce it into reduced row echelon form?
You just divide by that entry, right?
Oh, yes, yes. Yeah, yeah. Yes, ma'am.
Excuse me, ma'am.
Yeah, there was someone.
Can you tell me question number 6 of activity question 2.5?
Okay. We discussed this, right?
Yes,
Sorry,
ma'am.
ma'am, I joined late.
Yeah, we discussed this.
Can you again, please?
Ma'am,
Yeah, so
in
this is
this
the given
particular
matrix,
question,
right?
in this particular question, you said you could also multiply the first row by -1. I tried that and I could not come to the answer.
Maybe you will get some m1 minus m2 or something, and then you will have to solve that system to get the value of m1 plus m2.
I was not able to come to the answer.
Okay, so this is the matrix given, right? And this is the RREF of the matrix that is given. Yeah, so I'm just trying to find the RREF, that's it. And once I reach that stage, I'm equating.
I have to eliminate here only.
It's given, no? It's given that the second column of RREF is 0 and 1. So this is 0, this is 1.
Okay, thank you.
Okay, so suppose we do minus. So if I multiply the first row with -1, I'll get 1 minus m1 minus 2. And then I'm going to make this entry 0. For that, I will add 1. Okay. Okay, in this case, you're not getting
won't
because this
we
entry is
subtract?
-2.
Won't we subtract?
Is it? Okay, I directly did something.
Okay.
So this is what? 1 m2 minus 1. Okay, now I will subtract 1 minus 2, 1 minus 1, m2 plus m1. You'll get the same thing, right?
Yes.
This plus this. Oh, minus 3, is it?
No, I think +1.
Yes, yes.
Oh, subtracting. Okay, fine. Fine. So this is not the form that is given to us, right?
Yes, yes. That's why I got stuck.
So you want this entry to be -1.
Yeah,
Can
and
you
then if
make
you
it
divide by
minus?
2, then it's
It
sort
is
of
going to
spoiled.
disturb this. Yeah.
Yes, it's not possible by -1. So in exams, say we have to think of doing it some other row operation if we're not coming to the answer.
It won't. In exam, we will make sure there is no ambiguity at all.
You can do R1 plus R2 over here to get -1 over there.
No, but that's going to disturb this, no? The 1, 0 thing.
What thing, no?
So that will give, I think, 1 and m2 then -1 in the first row. 0.
What is
we
the
can
operation?
we can also do R1 plus 3 R2.
R1 plus 3 R2. Okay.
No, 3 R2.
No, I don't want to disturb these entries, right? This 1 and 0. I want to make this entry -1.
Simply we can do R1 plus R2.
No, but then this entry won't be 0, no?
No, this entry
No,
will
no.
be 0, no, because
R1,
we are
R1 equal to R1 plus R2.
Yes, ma'am. R1 equal to R1 transport to R1 plus R2.
Okay. Then 1, 0.
That thing will be
M2.
-1.
Fine.
So I think that will be the same.
Yes, we've come to the
Yeah.
answer.
Now it is the same. Oh, that's what we got earlier as well, right? Yeah, this one.
Yes, yes, yes. Thank you.
Yeah, fine. Awesome. This is great.
Hello, ma'am.
Yeah.
AQ 2.3, question number 9.
2.3, question 9.
Could you discuss option 2, 3, and 5?
Choose the correct options, okay? The
2,
adjoint of,
3, and 5.
okay, 2, 3, 5. There exists a square matrix of order 3 such that, okay, can you tell me any matrix such that it's equal to its inverse and its adjoint?
Identity matrix.
Yeah, that's it, right?
Okay. Or question number, option number 5. How got this answer?
1, 2, 3, 4, 5.
Is there,
If
ma'am,
A is
is there
equal to A
any,
inverse, then A squared is I. Isn't that obvious? You multiply both sides by A.
Okay, okay.
is there only one matrix which satisfy that? Option number 2?
No, no. Option 2 is it?
Yes. That is only one identity matrix.
We don't know. I have to check.
Okay, done, ma'am.
Yeah. One thing is for sure, A inverse is equal to adjoint of A means determinant of A has to be 1. And A should be equal to A inverse. I'm not sure.
Because, ma'am,
Might be possible. So we don't know.
Huh? What?
Might be possible, but we don't know.
Yeah. It's a 3 cross 3 matrix, right?
ma'am, because A inverse is equal to I, no, that's why.
No, this does not mean A is equal to plus or minus I. This does not mean that.
And because A is equal to A inverse, no?
Yeah, the inverse exists, yeah. So,
yeah, so that's why.
Yeah, I think it is going to be only identity matrix. But don't take my word for an answer. Try to find that.
Yeah, I tried today, so I realized like that only. I don't know.
Oh, okay. Square is identity. Okay, at least at this point, even I think identity matrix is the only one, but I'm not sure. Maybe I'm missing out on something. Yeah. If I'm wrong, then maybe I'm missing out on something. But at least with what I can see now, I'm getting only identity as the answer. Okay. What other?
Activity question 2.6. 5, 8.
Question number?
5, 8, and 9.
5, 8, and 9.
In the question 5, there is a third option. There is, ma'am. Can you explain this one? I could not understand in lecture also.
Okay, so suppose you have Ax is equal to B where B is 0. Ax is equal to 0. The question is, if A is an invertible matrix and the system has no solution. Firstly, tell me, this is a homogeneous system, right?
Yes.
It always has a solution, right?
Yes.
The question is whether it is a unique solution or infinitely many solutions, right?
Yes.
The unique solution is the 0 solution, right?
Yes.
And this is possible?
Yes, ma'am, possible.
Only when? What is the
When
condition?
Non-zero.
equal to 0.
When you do the reduced row echelon form and you get this. Only then you have the unique solution, right?
Or yes, ma'am.
And this is possible only when the matrix is invertible, right?
Yes, ma'am.
So the first one is not true because no solution is never a case.
Second is true.
Yeah.
But
The third is also true, right?
Yes, true, but I could not understand what is the meaning of this.
The trivial solution means the zero solution.
Okay, X.
If it has a unique solution, you already know what the solution is, right?
Yes, ma'am.
The zero solution.
Hello, ma'am.
Yeah.
How to find any matrix invertible or not?
By calculating the determinant?
If determinant is not zero, then it should be.
Okay.
Yeah.
Ma'am, can you
So is this
explain again that option, ma'am, the trivial solution? I'm not able to get it completely, ma'am.
So do you agree that Ax is equal to 0 has a unique solution if the determinant is non-zero?
Yes, ma'am.
So unique solution means what? It has only one solution, right?
Yes.
Can you give one solution to the system?
Yes,
irrespective of what A is?
if
zero.
Yeah, the zero solution, right?
Yes.
That's called the trivial solution.
But yeah, okay, ma'am. I got, since it has unique solution, trivial solution is the only solution for this.
Yeah.
Okay.
Ma'am, 8 and 9 also.
8 and
10
9.
also.
Suppose P is a matrix, okay. X naught is a vector, okay. Find the sum of elements of X, okay. You have a relation P xn minus 1 is equal to xn. You are given x2.
Fellow student is also given on discourse, but I could not understand.
You're given x2, right? So you know P x1 is equal to x2 using the relation, right?
Yes.
Is P invertible? Yes, it is, right?
Yes.
Yes, ma'am.
So can you find x1 from here?
Yes. P inverse x2.
Yeah. In fact, from here only you can tell xn minus 1 is P inverse xn. So you find out x1 and then find out x0. That's it.
Ma'am, I have a query.
Is this clear? Whoever asked the doubt?
Yes, ma'am.
Okay. Yeah. What is the question?
Ma'am, all homogeneous equation have two cases for their solution, and the cases are it will have a unique solution or it will have many solution. Won't it be possible that it will have no solution?
No, I can always give a solution. No, x is equal to 0 is always a solution.
Okay, if the determinant of A is 0, then it will have many solutions.
Yeah.
Okay.
Okay. And then the ninth
Hello, ma'am.
question.
Ma'am, this question is not clear. Question number 8, how it is being calculated, because it seems like.
This relation is given, right?
Yes, ma'am.
So you have a system of equations. Ax is equal to b. How will you find out x if A is invertible?
A inverse equal to B.
X is equal to A inverse b, right?
Right.
That's what we are doing here. Xn minus 1 is P inverse Xn. So from x2 you will get x1. From x1 you will get x0. Okay, question 9 also you had asked. Consider the system. Okay, the system has. Oh, this you just have to do, right?
Doing, but I don't know what mistake I do. In this question, two options
You
is
have a
3
3 cross 3
dependent
system.
variable. Here we find the unique solution. It is okay. Here is 3. Can you scroll up? 3 dependent variable. I think this.
Yeah, if you have a unique solution, you should definitely have 3 dependent variables, right?
Okay.
If you're having a unique solution, It means that the reduced row echelon form is identity matrix, right?
Yes, ma'am.
Every column has a pivot, so you have a dependent variable.
Okay.
Yeah.
10th question, please.
10th, is it?
How to find C and D?
No, you needn't find C and D. Options are given here. If C is this, D is this, then you have to find out what the system has.
So in this, ma'am, in this question, I do that first we write an augmented matrix and reduce into, then we put the value of C is equal to every option, then we find the solution.
Yeah.
Is it okay?
Yeah, that's how you do it.
Hello,
Thank
ma'am.
you.
Yeah.
Ma'am, can we say that reduced row echelon form of every invertible matrix will be identity matrix?
Yes. Can you tell me why?
I don't know, madam, but I am asking.
It will be. Maybe you can think about why it will be. Why can't it be any other matrix? Yeah.
Can the statement be repeated? Reduced row echelon form?
The reduced row echelon form of every invertible matrix is the identity matrix.
Yes, ma'am. In some tutorial, you also explain very well.
Oh,
Which
is it?
tutorial, madam?
A inverse about the how to find the A inverse through augmented matrix and reduce row echelon form.
Yeah.
Can you tell me
So
my
basically, you
explanation?
can find inverse. You start with the identity matrix on this side, and then you should end up with the identity matrix on this side to get the inverse, right? That's what you're
Yes, ma'am.
telling, right? Yeah.
Yes, yes. So we this method is quite easy. Then educate.
Adjoint. Yeah. Yeah.
Ma'am, that inverse one, can you please repeat once? Please?
What I was telling is the RREF of every invertible matrix is the identity matrix.
Ma'am, can I try giving an explanation? Can you correct me if I'm
Yeah,
wrong?
sure.
So reduced row echelon form of every invertible matrix. So invertible matrix means that there exists determinant, which means that we don't have any row being zero. So that means that we will have pivot in every single column. So when there is pivot in every single column, and we have, since it is in reduced row echelon form, which
Yeah.
means the other values are zero, so it is always identity matrix.
Yeah. Right. That's all.
Thank you, ma'am.
You cannot have a zero row. That's it. Right? And when you
Yes, ma'am.
cannot have a zero row, every column has a pivot. Any other questions?
I think no, ma'am.
Ma'am, in chat I have some questions.
Okay. Can you please give a date of session? What is it? Can you please give date of session in which RREF is used to find inverse? Oh, it must be the previous session because I did not discuss it in my session, so it must be the previous one.
Excuse me, ma'am.
Hello, ma'am.
What is the question
Ma'am.
on chat?
Oh.
Ma'am, that matrix equal to its own inverse, that one I found something that I wanted
Yeah,
to confirm.
involutory matrix, yes.
So there were many
Yeah.
examples given.
Yeah, but no, that is there. There are a lot of matrices having this. condition. But is that also equal to the adjoint of the matrix?
Okay.
That condition is, so that is putting an extra condition, the determinant has to be 1, right?
It says determinant can be plus or minus 1. Like it is very complicated article. I could not understand most of it. That is why I just shared it.
No, it's a simple thing. A squared has to be equal to I. In addition to that, you want it to be equal to the adjoint as well. Yeah, so all these cases, we just need to check whether it is equal to the adjoint. Oh, this is possible, I think. Oh, yeah, this is possible. So it's not just the identity matrix.
Others are also possible.
Yeah. The inverse is itself. What about the adjoint? 1, 0, 0. So 1, 0, 0. This adjoint, this one, 0, minus 1. Yeah. Okay, so this is a matrix which satisfies A is equal to A inverse is equal to adjoint. Okay, fine. So it's not just the identity matrix. Fine, thank you so much. Huh?
I'm audible to you?
Yeah, yeah.
I have a question regarding cofactor matrix.
Okay.
When do we need to change the signs in the of the elements?
So minor does not involve sign. Cofactor involves sign.
Yes.
This is a signed minor.
In 3 by 3 matrix or something like this. Am I right?
So you just multiply with minus 1 power I plus j into minor.
Okay.
Yeah. This is cofactor.
And in what about in 2 by 2 matrix?
In 2 by 2 matrix, what?
Can you write A? Sorry, 4 minus 3.
4 minus 3.
6 and 5.
Okay.
If I want to calculate the
minor of 4.
Adjoint of this matrix.
Okay.
Right, 5. So 5 and 4. Yes.
Yeah. You just interchange these two entries and then change the sign of these two
signs. Okay. And what to do in 3 by 3 matrix?
No, you cannot do anything
by
like
applying
this. You
this
have
principle.
To calculate. You have to calculate.
Okay,
There's nothing like this.
Okay. Is it possible if I can change the diamond shaped signs in 3 by 3 matrix? If I change the diamond shaped sign.
Yeah, signs will be like that. Yes, plus, minus, plus, minus, plus, minus, plus, minus, plus.
Minus
that's
is
because
diamond shape.
Yeah.
Okay.
That's because this index is the 1/1th index. So in all the places where there is a plus, the indices add up to even number.
Correct.
Yeah.
Thank you so much, ma'am.
Yeah.
Hello, ma'am.
Yes.
Ma'am, I have some doubt regarding vector space, madam.
Okay.
In terms of vector space, if we take any vector like v1, v2, v3, which is element of any vector space v, then what is the meaning of v1, v2, v3, madam? I am not
So V is a
understand.
vector space.
Yeah.
And these three are elements of V. That's it. It depends on what the vector space is.
V3 is the element of V.
Yeah.
Okay.
That's what you said, right?
Suppose we take R power 3 vector space, R cube vector space. Then what is the meaning of V1, V2, V3.
V1 is an element which has something 3 entries. V2 is an element which has 3 entries.
Okay, 3 entry.
3 components, yeah, because it's an R3. If it was an R2, it would have had 2 components.
Okay.
Yeah.
In R5, it has
5 components. Yeah.
Okay.
So each one is a vector in R3, means each one has 3 components.
Okay. And 3 different type of variables. Three
Component
components.
should be in column or row.
We usually take vectors as column vectors.
Okay, ma'am.
Column vector.
Excuse me, ma'am.
Yeah.
How we find the number of solutions of system of linear equation? How we
So
find?
you do the reduced row echelon form or row echelon form, and then you solve the reduced system. So that's what Sir has explained, right? You have Ax is equal to B, you reduce it to some Rx is equal to C, and then solve this system. This system is easy to solve, no? From this solving this, you will know how many solutions this has.
Okay. Okay, ma'am.
Hello, ma'am.
Yeah.
Why system of linear equation X is equal to B have same solution of Rx is equal to C? Why
Yeah, you should tell me.
Why it is happening?
Sir has explained this in the video, right? Or no?
Because
Yes,
row
ma'am.
How are you
operations
getting?
don't change anything.
So the operations that you're doing on A to get R is not going to change. You're either
matrix.
multiplying an entire equation with a constant, or you are adding. See, that's what you do basically in row elimination and
Operations.
substitution, right? Yeah.
Okay, because
So that's the operations don't change the solutions to the system. That's it.
Ma'am, what you just said about equations, like is that is how the matrix row operation was also made? Like I just found by comparing, like many operations are exactly same as solving equations, where we try
Yeah.
to eliminate variable like multiply the above equation or subtract an equation to eliminate a variable. It is just the same, but just that the variables are not there, only the numbers are there.
Yeah. I don't know if that was formulated from this, but definitely they are the same. Means whatever we do
There's
to each.
correlation, very strong correlation.
Yeah. I don't know
That's
which one was developed first. Yeah.
Yes, ma'am.
Yeah, ma'am,
Also, ma'am,
I have a
one
question.
question. Okay.
You carry on.
Go on. Okay, thank you. Like trivial solution means zero as the solution or
Yeah.
infinite solutions?
No, trivial solution means this solution, the 0, 0, 0 or 0,
Means all
0, whatever.
solutions are zero.
Yeah.
Okay. Thank you.
Ma'am, could you please open tutorial 1?
Okay.
At the end of the tutorial, it is showing that some 3D figures are being shown, but we are not.
But you are not?
In the last few minutes, we are not allowed to use that tool. Is it important from examination point of view or?
No, I think he was explaining it using GeoGebra.
Yes, but we are not allowed to.
Where is it?
It is not coming in tutorial. Can you please open tutorial 2?
I don't think it's on this one. Yeah.
Yes, this one.
Yeah, so he is just explaining using GeoGebra, that's it.
is it important from examination point of view or just for
No, no,
understanding?
this is just a tool which you can use to understand things, visualize things.
But not from examination point of view.
No, no, no.
Fine. Thank you.
Yeah. Okay, then shall we close?
You have explained question number 8 from mock test. I have one small doubt.
Okay.
If I equate these two equations, I will get a relation between x2 and x4.
Yeah, so we had discussed this question. Were you there when I discussed?
I have listened to that, but when I was solving this, I have found the final equation as x2 equals to 1 minus x3, and from that I assume that x2 is dependent on x3 and there is only one independent. So I think there is a misunderstood by me, but
no, x1 is not even appearing in the equations, no? So that is also independent, right?
yeah, but if you means make it to reduced row echelon form, and you will get two solutions like x2 x4 is equals to x2 and x4 is equals to 1 minus x3. When these two equation, if you omit x4, then you will get a relation between x2 and x3. It is x2 equals to 1 minus x3. So that final equation, I assume that x2 is dependent on x3. So only one independent variable in that case. So means why can't we understood like that?
No, see, I agree x2 is equal to 1 minus x3 or whatever. Yeah, 1 minus x3, I guess. Okay, fine. But this is not it. Everything, right? There is one more condition. You are ignoring the fact that x3 is equal to 1 minus x4. This is not the only equation from that comes out of the system. Right?
Correct.
So along with this.
So if means in this row echelon form, wherever is pivot, that is a independent variable.
Dependent
variable. Okay.
Yeah.
Thank you.
Ma'am, small doubt. Shall I ask now, ma'am?
Yeah, sure.
Ma'am, actually, that one question is there, no, in 1.5, activity question 1.5 and
1.5 is it?
Yes, ma'am. Question number 8.
Okay. Okay.
Ma'am, the determinant of A is equal to 8, like how do we take the values of that matrix? Like, is it that upper triangular matrix I should take the value 2, 2, 2 like that and I will calculate as 8, or is that in other way? Because
you have to write down the matrix. You can write down the matrix explicitly, right, from here.
Ma'am, it is a lower triangular matrix that I believe, and because it will be so I greater than j means like x value will be yes, that will be
When
higher
the
one.
number row value, the row index is less than the column index. So whenever that happens, the entries are 0.
Ma'am, I is greater than 0, right? So I is rows and I should be greater.
I is less than j, it is 0.
Okay. Yes. In that,
other cases, it is going to be 2, right? This is the matrix, right?
Okay.
So the product of the diagonal entries is the determinant.
One more question.
Ma'am, one more question.
Yeah.
Ma'am, that just question number 10. B is equal to 3A. Like, is it the 3 times of matrix A? And whatever determinant of A is there. So how do I get, like, it is A square means that it will be 16, right?
What is B? 3A. So A squared B is going to be 3A cube, right?
B is equal to 3A, yes. And now it will be determinant of 3A cube. and cube is 1 and 3a will be 3 times of 4. It will be 12.
No, determinant of 3a cube is going to be 3 cube times determinant of a cube, right? Because it's a 3 cross 3 matrix.
Ma'am, that term, can you please write that line? The determinant of 3a cube means it will be 3 times of determinant of a, right?
Determinant of 3a cube is going to be 3 cube times determinant of a cube. Since A is a 3 cross 3 matrix.
Okay, ma'am.
From each row, you pull out a 3, right? To calculate
Yes,
it.
I got confused here because what I understood, maybe I just pulled out the 3 alone and I did.
Yeah.
Yeah, ma'am. Similar to that, there is a question on mock, question number 6.
Yeah, I got that question.
I think I am getting some wrong answer in that. Question number 6.
Okay. Yeah, this was discussed in discourse. I had answered on discourse.
So the answer is right. Whatever we are getting, 256 is correct, or some.
Yeah. 256 is right. You'll get what? 4a. So you'll get 4 cube into determinant of a. So 4 power 4, 256. Yes.
4 cube means a plus b. So determinant of a plus b is determinant of a plus determinant of b.
No.
That is determinant of a plus put the value of b.
Okay.
Determinant of 4a.
Okay.
So 4 cube into determinant of
Okay. Any other questions?
Ma'am, can you please explain the approach of question number 5 in graded assignment? Only
Graded.
the approach.
What is the question? It's not the same for everyone,
Number
and the number
5.
definitely. No, it is not the same for everyone. Means the number will also not be the same. I might not even have that question here. Can you tell me which question it is?
Yes. Scroll down. Again. Yes, this one. Question number 5.
Okay. You just have to solve the system, right? You have a square system, so what do? That's the hint.
And madam, for 15, what will be the approach, madam?
What is 15?
Question number 15.
This one?
Oh, yeah. What?
I don't remember. I don't remember what this maximum number of vehicles and all is. So only if I solve, I will know what it is.
Okay.
Yeah.
Can I ask something?
Yeah, sure.
Is it possible for you guys to, as you guys are doing the great job, I must appreciate it. Is it possible for you to share the PDF or upload the PDF of the activity questions also?
Oh, no. Activity questions, we don't want to do it because if we do it, then you won't try it from your end, right?
No. I'm asking about the explanation part, where we are wrong, something like this.
So you're telling you want a feedback for the answer kind, is it?
Correct. Feedback. Feedback is the right word. Feedback is the right word.
Like what you get in Solve with Us.
Yes. How do we get the answer?
Ma'am, please upload the today's notes in the portal.
Sure. So I will discuss about the feedback thing.
Yeah, thanks so much.
Yeah, this has been, this is a common problem. Mock showing not completed or something. We have informed the support team. Okay, I guess we can close then, right?
Right, ma'am.
Yeah.
Yes,
Thank you, ma'am. Thank you, ma'am. Good night, ma'am.
Good night.
Thank you very much, ma'am.
Thank you, ma'am.
very
Good
much
night.
for this wonderful session.
Thank you, ma'am.
Thank you, ma'am.
Good night.
Thank you, ma'am. Good night.
Thank you, madam.
Thank you, ma'am. Good night.